Spiders have been crawling across Earth for hundreds of millions of years, long before the first dinosaurs appeared. These remarkable arachnids have survived multiple mass extinctions, adapted to changing climates, and evolved into thousands of unique species that continue to thrive today. But how did they begin, and what did ancient spiders look like compared to the ones we see today? From primitive spider-like creatures with tails to giant web-spinning predators, their evolution is a story of survival and transformation. Imagine a world where massive spiders roamed the prehistoric landscapes, spinning webs large enough to trap ancient insects the size of birds. These early spiders developed powerful fangs, venomous bites, and silk spinning abilities that would eventually make them one of the most successful predators on Earth. What adaptations allowed them to thrive while other species perished? Was it their ability to camouflage, their mastery of ambush hunting, or their unmatched patience in waiting for prey? The answer lies in their extraordinary ability to evolve, innovate, and conquer nearly every habitat on Earth. Their journey from primitive land crawlers to complex web-weaving hunters is filled with astonishing evolutionary changes, making them one of the most fascinating creatures to ever exist. Stay with us as we uncover the incredible journey of ancient spiders and how they became the masters of stealth and survival. Like and subscribe to explore more mind-blowing stories of evolution and nature's most fascinating creatures. 1. The first spider-like creatures, a world before webs. Long before spiders as we know them existed, their ancestors were already lurking in the shadows of the ancient world. Over 400 million years ago, the first arachnid-like creatures crawled onto land from the ocean, marking a major evolutionary leap in the development of modern spiders. These primitive creatures, known as trigonautarbids, resembled modern spiders in appearance but lacked some of their defining characteristics. Unlike today's spiders, trigonautarbids had segmented bodies similar to scorpions, suggesting that both groups shared a common ancestor. They lacked silk spinning capabilities, which meant they couldn't weave webs to trap prey. Instead, they relied on brute force, sharp fangs, and powerful legs to hunt down smaller arthropods. Some species even had long, whip-like tails, a feature that later disappeared as spiders continued to evolve into more specialized forms. Fossil evidence shows that these ancient arachnids thrived in the dense forests of the Devonian period, where they played a key role in controlling insect populations that were just beginning to dominate the land. Without silk or advanced venom, their survival depended on a combination of stealth, ambush tactics, and sheer speed. Over time, their bodies became more refined, and new evolutionary adaptations began shaping them into the spiders we recognize today. These early hunters paved the way for modern spiders, proving that even the most primitive arachnids had an important place in Earth's ecosystems. 2. The rise of true spiders. How silk changed everything. One of the greatest evolutionary breakthroughs for spiders was the development of silk spinning abilities, which completely changed their hunting strategies and survival techniques. Around 300 million years ago, the first true spiders emerged with spinnerets, specialized silk-producing organs that allowed them to create strong, sticky threads. At first, silk was mainly used for lining burrows, protecting eggs, and creating draglines to escape predators. But as spiders perfected their craft, silk became their ultimate survival tool, allowing them to outcompete many other predators of their time. Web-building spiders gained the ability to passively catch food instead of actively hunting, giving them an enormous energy advantage. Some species began constructing elaborate orb webs to catch flying insects, while others wove dense funnel traps or sticky sheets to snare unsuspecting prey. This adaptation allowed spiders to dominate multiple ecosystems, from humid rainforests to dry deserts and underground caves. Their adaptability skyrocketed, and with it, their numbers exploded, leading to the rapid diversification of different spider species. As their silk-producing abilities evolved, some spiders developed specialized silk that was stronger than steel by weight, making it one of the most advanced biomaterials in nature. With silk as their secret weapon, spiders not only secured their place in nature but also became one of the most widespread and successful predators on Earth. Today, spider silk is still being studied for potential applications in medicine, engineering, and even space exploration. 3. The age of giant spiders. Prehistoric arachnid titans. Millions of years ago, Earth's atmosphere had significantly higher oxygen levels than today, allowing arthropods to grow much larger than they do now. During the Carboniferous period, some of the largest spider-like creatures ever recorded roamed prehistoric forests, stalking their insect prey in a world vastly different from ours. One of the most terrifying arachnids of this era was Chimerarachne, an enormous creature that was originally thought to be a true giant spider. However, later studies revealed that Chimerarachne was actually a close relative of modern sea scorpions, but its discovery still provided insight into what ancient spiders might have looked like. Despite Chimerarachne not being a true spider, it sparked interest in whether prehistoric conditions could have supported the evolution of massive web-spinning arachnids. While no true spiders of monstrous size have been found, fossil evidence suggests that ancient spiders may have been much larger than their modern relatives. Imagine a world where tarantula-like spiders the size of dinner plates lurked in tree canopies, waiting for unsuspecting prey to pass by. While today's spiders are limited in size due to oxygen constraints, their ancient relatives may have pushed the boundaries of arachnid evolution, ruling over prehistoric forests in ways we can only imagine. 4. Spiders' deadly evolution. Venom and hunting tactics. One of the most powerful tools in a spider's arsenal is venom, and its evolution changed the game for these tiny predators, giving them the ability to immobilize prey instantly. Early spiders relied on brute force and ambush tactics, but as their fangs and venom glands developed, they became far deadlier and more efficient hunters. Some of the earliest fossilized spiders show evidence of hollow fangs, designed to inject paralyzing toxins into their victims. Over millions of years, spiders diversified into venomous hunters, each species specializing in different ways to capture and consume prey. Some developed neurotoxins that attack the nervous system, causing paralysis in seconds, while others evolved digestive venom that liquefies their prey from the inside out. These deadly adaptations allowed spiders to take down larger and more dangerous prey, including insects, small amphibians, and even birds in some cases. Venom not only gave spiders a hunting advantage but also helped them conserve energy by immobilizing their prey before eating. Today, spider venom is so powerful that scientists are studying its potential medical applications, including pain relief, blood clot treatments, and even possible cancer therapies. The evolution of venom turned spiders into some of the most efficient predators on the planet, ensuring their survival for millions of years. 5. The survival of spiders. How they outlived the dinosaurs. When the asteroid impact wiped out the dinosaurs 66 million years ago, many species perished in the aftermath, but spiders thrived. Unlike large reptiles that depended on specific ecosystems, spiders were adaptable, allowing them to survive one of the most catastrophic extinction events in history. While larger creatures struggled with food shortages and climate change, spiders continued spinning webs and hunting smaller prey that remained plentiful. Many species had already evolved to live in underground burrows or hidden crevices, making them less vulnerable to drastic environmental shifts. Their ability to reproduce quickly and adapt to new environments allowed them to flourish, while countless other species vanished from the fossil record. The extinction of the dinosaurs cleared the way for the rise of mammals, but it also allowed spiders to diversify further. Their resilience proved that size and strength are not always the keys to survival. Sometimes, adaptability and patience win in the long run. As other prehistoric creatures disappeared, spiders continued to evolve, solidifying their place as one of Earth's most successful predators. 6. Spiders and the changing world. Adapting to new climates. As Earth's climate shifted over millions of years, many species struggled to adapt, but spiders proved to be some of nature's greatest survivors. They have withstood ice ages, desert expansions, and even drastic changes in atmospheric oxygen levels, all while continuing to thrive in nearly every corner of the planet. Their ability to evolve new hunting strategies, develop more advanced silk, and modify their behaviors allowed them to survive in environments that became uninhabitable for other species. Some spiders adapted to extreme cold by developing antifreeze-like proteins in their blood, allowing them to survive freezing temperatures. Others evolved to live in scorching deserts, where they became expert burrowers, hiding beneath the sand during the hottest parts of the day. In rainforests, certain spiders learned to glide through the air, using their silk as a parachute to escape predators or travel between trees. Even in human-dominated landscapes, spiders have found ways to thrive, often hunting pests in urban areas and even adapting to artificial lights that attract insects. As the planet continues to change, spiders will likely evolve even further, proving once again that they are one of nature's most adaptable creatures. 7. Evolution of spider intelligence. More than just instinct, spiders are often seen as simple creatures that rely solely on instinct, but recent studies suggest they are far more intelligent than previously thought. Some species, like jumping spiders, have demonstrated problem-solving abilities, memory, and even the capacity to plan their hunts in advance. Unlike web-spinning spiders that passively wait for prey, jumping spiders actively stalk their targets, using advanced vision to analyze their surroundings before making a move. Research has shown that some can recognize and remember prey from previous encounters, adjusting their approach based on past successes or failures. Certain web-building spiders have even been observed adjusting their web designs based on environmental conditions, reinforcing weaker sections when expecting strong winds or modifying thread tension to improve capture efficiency. Social spiders, which live in colonies, show cooperative hunting behaviors, working together to capture larger prey that would be impossible to catch alone. These discoveries suggest that spiders are not just mindless predators but highly adaptable creatures with the ability to learn, strategize, and refine their survival techniques over time. 8. The role of spiders in the ecosystem. Nature's pest controllers. Without spiders, the world would be overrun with insects, disrupting ecosystems and harming plant life. Spiders play a crucial role in maintaining ecological balance by keeping insect populations in check, preventing outbreaks that could devastate crops and forests. A single spider can consume hundreds of insects in just a few weeks, and collectively, spiders eat between 400 to 800 million tons of insects every year. In agricultural areas, they help control pests that would otherwise destroy crops, reducing the need for harmful pesticides. Certain species, like wolf spiders, actively patrol fields, hunting down invasive insects that threaten food production. In rainforests, orb-weaving spiders form dense webs that trap vast numbers of mosquitoes and other disease-carrying insects, indirectly protecting larger species, including humans. Even in urban environments, spiders quietly work behind the scenes, keeping household pests like cockroaches and flies in check. Their role as natural pest controllers makes them essential to nearly every ecosystem on Earth, ensuring that insect populations remain balanced and preventing outbreaks that could have disastrous consequences. 9. Spider silk. Nature's super material. Spider silk is one of the most extraordinary materials in the natural world, with properties that surpass even some of the strongest synthetic materials created by humans. It is stronger than steel by weight, more flexible than rubber, and even tougher than Kevlar, the material used in bulletproof vests. Spiders produce different types of silk for various purposes, from building webs to wrapping prey, making egg sacs, and even using it as a safety line when escaping predators. Some species, like the Darwin's bark spider, create webs that span entire rivers, using silk that is 10 times tougher than Kevlar. Scientists are now studying spider silk for potential applications in medicine, such as developing artificial ligaments and ultra-strong sutures for surgery. Engineers are also looking into its use in space technology, creating lightweight but highly durable materials for spacecraft and protective gear. Despite countless attempts, humans have yet to replicate spider silk's unique properties synthetically, making it one of nature's greatest engineering marvels. As research continues, spider silk could revolutionize industries in ways we are only beginning to understand. 10. The future of spiders. What lies ahead? As spiders continue to evolve and adapt, what might their future look like? With rapid environmental changes caused by human activity, some spider species are already altering their behaviors to survive. Urban spiders are growing larger and becoming more aggressive hunters due to increased insect populations near artificial lights. Others are learning to survive in polluted areas, showing remarkable resilience to toxins that harm other creatures. Climate change may drive spiders to expand their ranges, introducing new species to regions where they were previously unknown. Scientists are also studying the possibility of genetically modifying spiders to produce even stronger silk, which could lead to breakthroughs in medicine, construction, and even military technology. As artificial intelligence and robotics advance, some researchers are looking at how spiders' movements and web designs could inspire new types of robots capable of navigating complex environments. While spiders have already proven their ability to survive for hundreds of millions of years, their future will likely be shaped by the challenges and opportunities of a rapidly changing world. One thing is certain: these ancient hunters will continue to weave their way into the future, adapting and thriving as they always have. From their ancient origins to their modern-day dominance, spiders have remained one of the most resilient and adaptable predators on Earth. They have witnessed the rise and fall of countless species, survived global catastrophes, and evolved extraordinary abilities that keep them at the top of their game. Unlike larger and more powerful creatures that vanished due to environmental shifts, spiders thrived by mastering stealth, efficiency, and adaptability. Their ability to produce silk, inject venom, and craft intricate traps gave them an evolutionary advantage that no other arthropod could rival. Across millions of years, they have spread to nearly every corner of the planet, from deep caves to the highest mountaintops, proving that their survival strategies are nearly flawless. Whether hiding beneath bark, burrowing underground, or swinging from tree to tree, spiders have perfected the art of living undetected while still dominating their prey. Today, spiders continue to play a crucial role in maintaining ecological balance by controlling insect populations and even inspiring human technology. Every year, they eliminate billions of pests that could otherwise devastate crops and spread disease, making them one of nature's most effective exterminators. Scientists study spider silk for its unmatched strength and flexibility, with potential applications in medicine, engineering, and space exploration. If researchers unlock its secrets, we could see ultra-lightweight armor, artificial tendons, and even space elevator cables built from bioengineered spider silk. Even venom, once feared, is now being explored for groundbreaking medical treatments, from painkillers stronger than morphine to potential cancer-fighting compounds. Beyond their scientific potential, spiders hold a unique place in human culture, inspiring myths, legends, and even technological advancements. From ancient cave paintings to modern horror films, these arachnids have fascinated and terrified people for generations. Some cultures view them as symbols of patience and creativity, while others associate them with fear and danger. Despite their sometimes sinister reputation, their true nature is one of balance and precision, shaping the natural world in ways we are only beginning to understand. As we unravel the mysteries of their evolutionary past, one thing becomes clear: spiders are here to stay, and their impact on the world is far greater than we ever imagined. They are living fossils, testaments to the power of adaptation and the art of survival. Even after hundreds of millions of years, they remain undisputed masters of their environment, evolving in silence as the world around them continues to change. So, the next time you see a spider spinning its web, remember that you're looking at a creature whose ancestors have outlived the dinosaurs, survived mass extinctions, and continue to shape the world in unseen ways. Who knows what the future holds for these remarkable creatures? If you enjoyed this journey into the evolution of ancient spiders, make sure to like and subscribe for more incredible stories about the hidden wonders of nature.